Good morning, students. In a previous class, that is a class 4, I will completed that is the term mole concept. That means during this class, I deduce the relationship between mole with number, that is Avogadro number, equivalent to gram molecular mass, equivalent to gram molecular volume, that is 22.4 liter at NDP. And also basing upon this, we frame some formula relation and also solve one problems. Today in class 5, I will try to complete 2 to 3 terms. That means, what do you mean by percentage composition of an element? What is empirical formula? What is molecular formula? And what is the relationship between them and problem relating to it? Let us start one by one. First is percentage composition. Mark that. Percentage composition. So what do you mean by the term percentage composition? Percentage composition of an element is defined as the number of parts by mass of an element is heavier than 100 parts by mass of the compound. Mark that. It is defined as the number of parts by mass of an element. It is defined as the number of parts by mass of an element is compared with that of 100 parts by mass of the compound. That means percentage of an element is equal to number of parts by mass of each element divided by total mass of the compound into 100. Mark the relationship. Percentage composition of an element, I repeat again, percentage composition of an element is equal to number of parts by mass of each element divided by total mass of the compound into 100. Let us apply this concept solving one or two problems. Next thing is how we apply this concept. So before solving this one, first we write the formula. Step 1, we write the formula. Then we calculate the individual atomic mass. Then add the sum total atomic mass to form the molecular mass. Finally, divide it and multiply 100 to find out the percentage composition of each element. Mark that question. Calculate the percentage composition of each element present in calcium carbonate. Mark the question. Calculate the percentage composition of each element present in calcium carbonate. So answer, first we write the formula of calcium carbonate, that is CaCO3. Mass is 40 plus 12 plus 48 equal to That means 100. So total mass of calcium carbonate is 100. Now percentage of calcium is equal to individual mass of calcium divided by total mass of the calcium carbonate into 100. Similarly, percentage of carbon, total mass of carbon divided by total mass of the compound into 100. This is equal to 40, this is equal to 12. Next is percentage of oxygen, the total mass of the oxygen 48 divided by 100 into 100. This is equal to 48%. So percentage of calcium is 40, percentage of carbon is 12, percentage of oxygen is 48. Similarly, move to another one type of problem. Calculate the percentage composition of each element present in glucose. Calculate the percentage composition of each element present in glucose. So what answer? What is the formula for glucose? C6H12O6. So we have to find out first its mass. 6 into 12 plus 12 into 1 plus 6 into 16. 72 plus 12, 96 equivalent to is equal to 180. Therefore, percentage of carbon. So total mass of carbon, that is 72 by 180 into 100. Percentage of hydrogen, total mass of hydrogen, that is 12 by total mass of the compound 180 into 100. Next, percentage of oxygen, total mass of oxygen 96 by 180 into 100. Solve this one, find out the percentage composition of each element present in the glucose. So whatever may be the formula, it may be glucose, it may be sucrose, it may be fructose, carbon dioxide, sulfuric acid, nitric acid, water, whatever may be, we follow same step. That means first we write the formula, then we calculate the individual atomic mass, then add the total atomic mass to find out the molecular mass, then we write individual mass of an element divided by total mass of the molecule into 100 to find out the percentage composition. So it is one type of formula to calculate the percentage composition. Move to another type of a problem. Next question is question number 2. Calculate the percentage composition. Calculate the percentage composition of water of crystallization. Water of crystallization in case of blue vitriol. We know the formula of vitriol, that is copper sulfate pentahydrate. Mark the question. In first type of question, we solve the percentage composition of each element, each species. But now we have to calculate only the percentage composition of water of crystallization. So answer, we follow the same procedure. That means answer, the mass of CuSO4 dot 5H2O is equal to copper 63.5 plus sulfur 32 plus oxygen 64 plus water is 90. On adding this total, this value is 249 249.5. So total mass of the compound is 249.5 and we have to calculate the percentage composition of water, that is 98. Therefore, percentage composition of water of crystallization is equal to total mass of water molecule 90 divided by 249.5 nearly equal to 250 into 100. If it is solved, then approximate value will be nearly equal to 36.03%. Mark that it is the second type of problem. Move to third type of problem. Question number 3, that is calculate the percentage composition of cation. Calculate the percentage composition of cation in case of ammonium chloride. In case of ammonium chloride, mark that. In case 1, in first type, we simply calculate the percentage composition of each element. In second case, we calculate the percentage composition of water of crystallization. In case 3, we calculate the percentage composition of either cation or anion. So, mark that ammonium chloride. We follow the same procedure. That means NH4Cl, that is 14 plus 4 plus 35.5 equivalent to 53.5. It is the total mass of ammonium chloride. Then we have to calculate the percentage composition of cation. Cation means when ammonium chloride break down to give ammonium ion and chloride ion. So here total we have to find out only the cation, that is NH4 plus, equivalent to 14 plus 4, that means 18. Therefore, percentage of ammonium, that means total cation, is equal to 18 divided by 53.5 into 100. Try to solve. This is the value. The value give the answer. That means percentage composition of cation. It is the little idea about the percentage composition of each element or water of crystallization, or that of percentage composition of cation or percentage composition of anion. Next, we switch over to find out the little idea what do we mean by empirical formula, what is molecular formula, how empirical formula related with a molecular formula, and some problems related to it. So first, I give a little idea about the two terms. One is molecular formula and one is empirical formula. Normally, in simpler concept, formula of a molecule is known as molecular formula. Formula, suppose we select a molecule that is glucose, that is C6H12O6. That means molecular formula represent the actual number of each kind of element present in that compound. It is known as the molecular formula. And if we took out the simplest ratio, remove the simplest ratio, what is left? That is known as the empirical formula. For example, mark that if we select glucose, that means C6H12O6. It is the actual formula of a molecule glucose, that is C6H12O6. So from this we mark that there is a common term, that is number 6. So by taking a common 6 we have, so here N is equal to 6, which is taken into common. By taking a common, it is equal to C1H2O1. That means this one is known as empirical formula. While molecular formula of glucose is C6H12O6, while empirical formula of glucose is CH2O or C1H2O1. Similarly, if we select a benzene formula, molecular formula, its molecular formula is equal to C6H6. Actual formula of a molecule is known as molecular formula. Molecular formula represent the actual number of atoms present in one formula unit. While taking common, that means n is equal to 6 by taking common here, that is empirical formula left. This is known as C1H1 or it is CH. Similarly, if we select acetylene, let us consider another example. If we select acetylene, like that acetylene, it is actual molecular formula is C2H2. The actual formula of acetylene molecule is C2H2. Here by taking n is equal to 2, by taking n is equal to 2, so empirical formula is equal to C1H1 or simply CH. Let us consider another example. Suppose water formula, its molecular formula is equal to H2O. Here a common is only 1, so put n is equal to 1. By taking common n is equal to 1, its empirical formula is equal to H2O. So from this 2 to 3 example, it is clear that molecular formula is related to empirical formula by a relation that molecular formula is equal to some integral multiple of empirical formula. That is, molecular formula MF is equal to n into empirical formula. Mark the relation. So from this example, we draw one conclusion that molecular formula is nothing but integral multiple of empirical formula. That is, molecular formula is equal to n into empirical formula, or in shortcut, or MF is equal to n into empirical formula EF. While calculating n is equal to molecular formula by empirical formula. So from this relation it is clear that while dividing the value of a molecular formula with empirical formula, the value of n may be a whole number or some fraction. If it is a fraction, maximum time whole number. If it is a fraction, then round up to nearest whole number to find out the value of n, because n always integral multiple. It may be 1, 2, 3, 4 like this. If it is a 0.98, if it is a 0.99, then we have to round up equal to 1. If it is 1.92, then equivalent to round up to next whole number, that is 2. So from this it is clear that empirical formula into multiply into whole number is equal to molecular formula, or molecular formula is equal to n into empirical formula. That means, come to the point, molecular formula is defined as, it gives a little idea, it gives a complete idea about the total number of actually present in one molecule of a compound, while empirical formula give the simplest whole number ratio present in molecule of a compound. It is known as empirical formula, and both are related by a formula, that is relation, that is molecular formula is equal to n into empirical formula, while calculating n, that is dividing molecular formula by empirical formula. Now let us utilize this concept for solving one or two problems. So question is that before going to question, mark that, before going to question, first thing we have to calculate the empirical formula. Remember that what are the different steps followed for solving this type of problem. First we calculate the empirical formula. Then we calculate the empirical formula mass. Mark that, 2 to 3 steps are there. First, we calculate empirical formula. Then second step, we calculate empirical formula mass. Next we calculate molecular formula mass. So it is the important one, how we calculate the molecular formula mass. In question it may be direct given, the molecular formula mass of that compound is given. In other words, another one relation also there, it is given in the question, vapor density is given. Remember that one relation, that is molecular mass is equal to 2 into vapor density. That means mm is equal to 2 into Vd. Molecular mass is equal to 2 into vapor density. So in question, either a direct molecular formula mass is given or vapor density is given. If vapor density is given, simply multiply to find out the molecular formula mass. So empirical formula mass calculated, molecular formula mass calculated. Then we calculate n is equal to molecular formula mass by empirical formula mass. It is maybe a whole number or fraction. If it is a decimal one, then round up to nearest whole number. As a result, n is calculated. So in the first step, we calculate the empirical formula. So last step is molecular formula is equal to molecular formula is equal to n into empirical formula. Okay, doubt clear? Then come to the another point is there. Come to the first point. How we calculate the empirical formula? Come to the another one point is there. How we calculate the empirical formula? For calculating empirical formula, again 3 to 4 steps is there. Mark that. Important thing is that how we calculate the empirical formula. 3 to 4 steps are there. It is better I try to clarify this one in the form of a table. Mark that, we have to frame one table. It is element, next percentage, next atomic mass. Mark that. It is column 1, column 2, column 3, then atomic ratio. How we calculate atomic ratio? That is column 4. Column 4 is equal to column 2 by column 3. Mark that. Column 4, element given in the question, percentage given in the question, or we have to find out. Atomic mass given in the question, or we have to remember. Then column 4 is calculated by dividing 2 by column 3. Next is simplest ratio, simplest atomic ratio, that is column 5. Then column 6, simplest whole number of atomic ratio, column 6. So while solving the problem, we have to make 6 column. I repeat again, column 1 that means element, column 2 that means percentage, column 3 that is atomic mass, column 4 that is atomic ratio. Atomic ratio is equal, how we calculate atomic ratio? That is percentage value divided by atomic mass. Then column 5 that is simplest atomic ratio, and column 6 is simplest whole number ratio. Come to the point. That is the first one, element given in the question. It is percentage either given, we have to find out. Next, atomic mass given or we have to remember. Divide this one, it is atomic ratio. Column 2 by column 3 give rise to atomic ratio. Suppose mark that this atomic ratio suppose is 1.22, 2.44 and 1.22. Suppose this value is there in column 4. Then how is switch over to column 5? Mark that which value is the lowest one. Which value is the lowest one? That one divided to each term. That means 1.22 by 1.22 equivalent to 1. 2.44 divided by 1.22 equivalent to 2. 1.22 divided by 1.22 equivalent to 1. Mark that. The result is a whole number. If result is a whole number, it is not always necessary that this result is always a whole number, may or may not. If it is whole number, then copy down to column 6, 1, 2, 1. If not a whole number, mark that. Suppose it is 1 and it is 1.5 and it is 1. Mark that. Suppose by dividing the result of the column 5 is 1, 1.5 and 1. Then select a suitable lowest integer, multiply suitable lowest integer in such a way to each term that total all of them is a whole number. That means I multiply 2, so answer is 2, 3, 1. So simplest whole number ratio is 2, 3, 1. So that means in this first case element, suppose carbon, hydrogen, oxygen. If it is a carbon, hydrogen, oxygen, percentage is given is 60, 40, 30. Suppose it is given in the question. Then atomic mass carbon 12, hydrogen 1, 16. But if you proceed like this one, we found that total number of atoms of carbon is 2, total number of hydrogen is 3, total number of oxygen is 1. So empirical formula is C2H3O1. This is known as empirical formula. Then we calculate its empirical formula mass. Mass of one carbon is 12. So 12 into 2 plus 1 into 3 plus 1 into 16. Add this one. This is known as empirical formula mass. Then in question, molecular formula mass is given or vapor density is given. If vapor density is given, multiply by 2. That is known as molecular formula mass. Empirical formula mass we calculate, molecular formula mass we calculate, then divide by molecular formula mass by empirical formula mass give rise to n. So n is calculated. Our result is, our aim is to find out the molecular formula. So molecular formula is equal to that whole number into empirical formula, which gives the answer. That means molecular formula of that molecule. So let us apply this concept while solving the problem. Mark the question. What is the data given? Question is, a compound is found to contain 30% carbon, 6.67% of hydrogen and 53.3% of oxygen. And data given, it's a vapor density. Vapor density is given, that is 30. So we have to calculate the empirical formula and the molecular formula. So first thing, we have to frame the table. Mark that. First one is element. Next one, percentage. Next one, atomic ratio. That means it is column 1, column 2, column 3, column 1 is element, column 2 is percentage, column 3 is atomic mass column 3, atomic ratio, column 4 is atomic ratio, column 4 is calculated by column 2 by column 3, then simplest atomic ratio, that is column 5, then simplest whole number of atomic ratio, that is column 6. Mark that. First is element given, that is a carbon, hydrogen and oxygen. Percentage given, carbon, that is 40, hydrogen given, that is 6.67, and the carbon is 40, this one is hydrogen, and oxygen is 53.3%. Then atomic mass of carbon is 12, hydrogen 1, 16, oxygen. Now column 4. We know column 4 is calculated by dividing column 2 by column 3. That means 40 by 12. 40 by 12 equivalent to 3.33. 6.67 by 1 nearly equal to 6.67. That is 53.3 divided by 16 nearly equal to 3.33. Mark that. Same procedure is there. Which one is the lowest one? Divide this one to each term. That is column 5 is equal to 3.33 by 3.33 equal to 1. It is 6.67 divided by 3.33 nearly equal to 2. 3.33 divided by 3.33 nearly equal to 1. As it is a whole number, then copy down 1 to 1. So from this table, it is clear that carbon present 1 times, hydrogen present 2 times, oxygen present 1 time. That means the formula, empirical formula, mark that. Now the empirical formula is equal to C1H2O1. Then we calculate empirical formula mass. Empirical formula mass 12 plus 2 plus 16 equal to 30. That means according to question, molecular formula mass we calculate, that is 2 into vapor density is equal to 2 into 30 is equal to 60. Now molecular formula is calculated, empirical molecular formula mass calculated, empirical formula mass calculated, then we calculate n. We know n is equal to that is, we know molecular formula is equal to n into empirical formula. So n is equal to molecular formula by empirical formula. That is molecular formula mass by empirical formula mass. 60 by 30 is equal to 2. By knowing the value of n, then we empirical formula we calculate. Then also we calculate the molecular formula. That means molecular formula is equal to n into empirical formula. Therefore, molecular formula is equal to 2 into C1H2O1. That means C2H4O2. C2H4O2 is the molecular formula. So while solving this problem, we follow the normal procedure. Whatever may be the data is different, but procedure is always same. So first we build up this table to find out the empirical formula. Then we calculate the molecular formula mass. Then we calculate the value of n. Finally, multiply the value of n with empirical formula to calculate the required molecular formula. So let us apply this concept while solving another type of problem. Mark the second question. What is the second question? An organic compound contains carbon, hydrogen and oxygen. 1.80 gram of the substance on combustion gives 2.64 gram of carbon dioxide and 1.08 gram of water. Then calculate the empirical formula. It is another type of problem. Here the individual percentage composition is not given. So our aim to find out the percentage composition, then build up the table to calculate the empirical formula. Mark that how we solve it. Answer. What is the data given? Data given that organic compound on combustion gives 2.64 gram of carbon dioxide. That is 1 molecule of carbon dioxide contains 1 carbon. This equivalent to nearly 44 gram is equivalent to 12 gram. So from this relation it is clear that 44 gram of carbon dioxide contains 12 gram of carbon. Mark that. That is 44 gram of CO2 molecule contain 12 gram of carbon. Then 1 CO2 content equivalent to 12 by 44 gram. According to question, the mass of the substance is 2.64 gram of carbon dioxide. Therefore, 2.64 gram of CO2 content is equivalent to, that is 12 divided by 44 into 2.64. 12 divided by 44 into 2.64. On solving this one, the value is 0.72. This is 0.72 gram of carbon is there. So next we calculate the percentage. Mark that. Next we calculate the percentage of carbon present. That means, therefore, the percentage of carbon individual mass, that is 0.72. Total mass is given 1.80 into 100. Total mass of the compound is given in the question, that is 1.80. Is nearly, by solving this one, equal to 30%. So 1% of carbon, that means percentage of carbon is evaluated. Move to next one. What is the question? Along with the carbon dioxide, water also eliminated. Water also involved. But how many fraction? 1.08 gram. That means H2O equivalent to 2H. That means 18 gram of water contain 2 gram of hydrogen. Mark that. That is 18 gram of water contain 2 gram of hydrogen. So according to question, 1.08 gram of water contain hydrogen. That is 2 by 18 into 1.08. That is 2 by 18 into 1.08. On solving is equal to 0.12 gram. Therefore, the percentage of hydrogen present, that is individual mass by total mass into 100. Individual mass of hydrogen we calculate 0.12. By total mass is 1.80. It is given in the question. On solving this one, it is nearly about 6.67. On solving this, nearly about 6.67. That means percentage of carbon is calculated, percentage of hydrogen is calculated. So our aim is to calculate the percentage of oxygen. So percentage of oxygen is calculated, that is percentage of oxygen is equal to 100 minus 40 plus 6.67. On solving this one, that means on solving the percentage of hydrogen, percentage of carbon and percentage of oxygen nearly is 100. If two are given, then third one is calculated, solving 53.3. Now we find out the percentage of carbon, hydrogen and oxygen. Now it is time to build up the table to calculate the empirical formula. So mark the table. That means first one is element, next one column 1 percentage, column 2, then atomic mass, column 3 atomic ratio, column 4. Column 4 is calculated by dividing column 2 by column 3. Then simplest atomic ratio, that is column 5. Then simplest whole number atomic ratio, that is column 6. Mark that. It is given in the question. Element are carbon, hydrogen, oxygen. Percent composition given, that is 40. Hydrogen we calculate, the percent of hydrogen is 6.66 or 6.67. It is given 53.3. Atomic mass we remember, that is 12, 1, 16. Column 4, that means column 2 by column 3 is equal to 3.33. 6.67 by 1 is equal to 6.67. 53.3 divided by 16 is equal to 3.33. Mark that. Which one is the lower one? This one is the lower one. So divide each term by this one. 3.33 equivalent to 1. 6.67 by 3.33. That is 2.001, which round up to 2, and it is 3.33 by 3.33 is equal to 1. Mark that. The value is a whole number. So copy down to next 1, 2, 1. So the empirical formula of this compound is now C1H2O1. It is known as the empirical formula. So it is the little idea about the percentage composition of an element, how to calculate the percentage composition of individual element, water crystallization and some cation or anion. Next, what do you mean by empirical formula? What do you mean by molecular formula? And how empirical formula and molecular formula interrelated, and some problem relating to it.